Hello YouTube, it is Qnix. I am here to bring you another tutorial today for an effect that I was recently asked to describe, and it's a pretty complicated effect, so I think that a video tutorial is going to serve you better than just answering through text. This is the X but the palette is Y video effect, where we take a certain video, but we use another video as a color palette, and we try to map the colors of our palette video onto the colors of the original video the best that we can. Now, this is an FFmpeg effect, and it makes extensive use of a filter called palette use. Now, palette use is a filter which downsamples colors in an image or video using a set of colors that are provided by the user through an image. Now, typically, for practical purposes, you either want this color palette to have a broad range of colors, which can reasonably represent any sort of picture, or you want to use the palette gen filter to create an optimized color palette, which specifically represents the colors in your image or video well. But the color palette that you use can be arbitrary. It doesn't have to be practical. For example, I made a video a while back where I generated a color palette that was exclusively shades of pink, and then I applied that to the Kirby Right Back At Ya theme song. And even though this color palette wasn't particularly practical, it didn't represent the wide range of colors in the original video well, FFmpeg still did its best to take the colors that I provided it and map them to the theme song. Now, because the color palette can be arbitrary, it only makes sense then that the color palette can also just straight up be a picture. This is something you'll basically never see if you're trying to use palette use for anything that is meant for practical purposes. But it is kind of fun to see what shenanigans FFmpeg gets up to when you give it an image that is definitely not meant to be used as a color palette, and you tell FFmpeg to use it as a color palette. It will still try its hardest to do so. If you use an image with the palette use filter, then FFmpeg will take the color palette you provide, and it will just treat every pixel in the image as a separate color, and it will then limit the other video you're working with to whatever colors are in your palette. So, I kind of already mentioned this, but the required software here is FFmpeg, and you need to make sure that you can use the palette use filter. Additionally, because I'm doing this on Linux, you're going to want to use GNU Parallel. This is going to help a lot because this is another effect that requires editing individual frames, and it is possible, I learned it is possible on Windows, at least modern Windows, to parallelize on the command line through PowerShell. There is a command line switch in the for each object command that's -parallel. Unfortunately, I don't quite know enough about PowerShell to help you structure the command line. So hopefully you guys, your Windows users, can figure out how to parallelize this. You don't have to parallelize it, but it will be very slow if you don't. So my demonstration, we're doing NixOS 25.05 with FFmpeg, GNU Parallel, and I am going to assume that you are rendering a widescreen video in 4K 60 FPS resolution. So, let's get started. In order for the best results, you want to keep a few things in mind. You're going to have two videos here. One is going to be the video that you use as a color palette, and the other one will be the video that takes that color palette and that you're going to alter the colors for. For both of these videos, you want to have a fairly diverse set of colors. And for the video that you're using as the color palette, you want to make sure that the colors actually change to some degree over time. And most importantly, that you can actually recognize the video if you shrink it down to an unreasonably small size. Because what we're going to be doing when we generate the video color palette is we're going to shrink it to a size of 16 by 16 pixels. And this is required because the palette use filter will only take color palettes that have 256 pixels. I don't think they have to be 16 by 16 squares. I think you could, for example, have 32 by 8. But just for ease of use, we're going to keep this to a 16 by 16 pixel square. So let me play the two videos I've selected. Main is the video that is going to use the color palette. So the end result is mostly going to look like this, but the colors will be warped. So let me play this example for you. Main. Oh no, he's coming. Oh no, he's coming. Ah, jump scare! Well, I hope I didn't scare you guys too much with that video, but I chose that video as my main video because it has a fairly diverse set of colors, and I think that it would be a good candidate for downsampling. Now, I'm also going to play for you the video I've selected to use as the color palette. And I call this palette source. Easy enough. So before I get into actually applying the effect, I did say it's important we make sure that the video doesn't have too much fine details, that if we shrink it down to an unreasonably small size, we can still see it. So what I'm going to do, just to demonstrate that the entertainment and video logo is going to work for this purpose, is I'm going to do that shrinking down, and I'll make sure I can still see the video. So I'm going to use FFmpeg, and my input will be palette source with video effects. Crop equals W equals 0.95 times IW, and H equals 0.95 times IH. Scale equals W equals 16. I'll be explaining this whole command line after I type it. H equals 16. Force original aspect ratio equals disable. And then scale equals W equals 720. H equals 720. Flags equals neighbor. So V, JPEG 2000, pred1, and test.mkv. So here's what's going on. I'm running FFmpeg to edit the palette source video. First, I'm trimming off the edges. So crop means my output width will be 95% of my input width, my output height will be 95% of my input height, and the very outer edges will be removed. Then I'm saying scale equals W equals 16, H equals 16, force original aspect ratio equals disable. What this means is that I'm shrinking this video to a size of 16 pixels by 16 pixels. And force original aspect ratio equals disable means that we are allowing FFmpeg to stretch the video as needed to fill a square. And alternately, you could maybe use Kdenlive to manually crop and stretch the video if you so choose, but ultimately you are going to have to get this to a size of 16 by 16. Then finally, I scale again, W equals 720, H equals 720, flags equals neighbor. Now, the reason why I'm doing this is because if I shrink the video down to a size of 16 by 16 pixels, I won't be able to see it. So I have to scale it back up to 720 by 720 so I can see it. And flags equals neighbor means that I am just going to scale up the pixels by making them giant squares. Typically, FFmpeg will use some blurriness to interpolate what the color should look like when you scale a video from a lower resolution to a higher one, but I don't want it to do that. I want to see exactly what the pixels are going to look like. Now, there's one thing I forgot. Luckily, it wasn't me mixing up colons and commas. I always do that. Before we begin, we want to set the color format to RGB24. The reason why is because most videos that you're going to be using as input sources will have this other pixel format, YUV 420p, which means that the color component is going to have half the resolution as the lightness component. Now, if you're working with moderate resolutions of a few hundred to a few thousand pixels, then this isn't much of an issue. But if you're scaling the video down to only 16 by 16 pixels and you keep this color format, it means you only have 8 by 8 pixels of color information. So we definitely want to make sure that we are not limiting ourselves to this color space before we do anything. I will also enforce this by setting the pixel format to RGB24. Now, this stuff at the end, CV equals JPEG 2000 Pred 1 means that I'm rendering this as lossless JPEG 2000. For this testing phase, you should render this as either a lossless or a high quality video. You don't want it to be too low quality because remember, you're looking at a very tiny video to see if it's going to work for your purposes. So if you use a lossy algorithm that reduces the quality too much, then you'll have an issue where this test that you're looking at isn't going to represent the color palette well. AN means no audio. I don't need audio for this. Test.mkv is just the name of the file. So let's render it and then play it. So what we're looking for is that we can still recognize the video even though we've shrunk it down to a ludicrously small size. And I would say that the video is still recognizable. Everything that we are familiar with from this video is pretty much still there. So I would recommend running this test before you do anything to make sure that the palette source is going to work for your purposes. Now let's get started on actually applying the video effect. Step one is we are going to, I don't want to say upscale, I'll get into more detail about this, but we are going to want to motion upscale as needed, but convert our main video into frames of a suitable size. So now I'm working with main. This is the video that's going to use the color palette. And I'll say VF format equals RGB24, scale, oh, not scale yet, crop equals W equals 0.95 times IW, and H equals 0.95 times IH. Scale. Now here's where things are going to get interesting. Usually when I upscale my video, I'm scaling it up to 4K resolution because my final output video is going to be in 4K resolution. However, we don't want to render this at full resolution just yet. The reason why is because when we apply a color palette to a video, FFmpeg has to use some algorithm to basically spread the colors over an area, because otherwise you get something called color banding, where instead of the colors being spread evenly across your video in smooth gradients, it instead looks like distinct regions of color with harsh changes. Now, if we render this at too high a resolution, it gets harder for FFmpeg to apply these algorithms that prevent the appearance of color banding. So I think a reasonable resolution to use is 640 by 360. Do feel free to play around with this. This is just something I find works well for my purposes. Just as an example, my wallpaper has a resolution of 640 by 360. If you lower this value, then you'll have less detail, but the colors may look better. They may look more even, and you'll have something more of a retro look. If you increase this value, then you'll have more detail, but you risk color banding. And I will force the original aspect ratio disable. Now I'm going to interpolate as usual. Not strictly required, but I usually do this as part of my upscaling process. Whoops. MI mode equals MCI. MC mode equals AOBMC. ME mode equals BIDIR. And VSBMC equals 1. And I think we should denoise this as well. So we've converted it to the right color format. We've trimmed off the edges. We've scaled it to 640 by 360. We've interpolated the frame so that we have a higher frame rate, and we've denoised. Now is the part where we convert it into frames. I'm going to do CV JPEG 2000, Pred 1. I'll enforce the correct pixel format just to be sure. And I'll call this frame 04D.jp2. So, why did I choose these? In a previous video, I talked about how I wanted to use JPEG 2000 for more things, but I found it just wasn't as practical as PNG. Well, I did some more tests on, with this particular effect, and I found that JPEG 2000 in some cases actually does produce smaller images than PNG, and it also has a variety of pixel formats available to it. So I think it's a bit more flexible. I'm going to be using it for today's example. You don't have to use the JPEG 2002 format though, especially if you're on Windows. You may have issues viewing JPEG 2000 files. So if you want, you can use PNG. PNG may be a little bit faster. If you really want good compression, you can use JPEG XL, which is a new format. In any case, though, whatever image format you use, you just want to make sure it's lossless. So you don't want to use something like ordinary JPEG, because JPEG is a lossy image format. It will reduce the quality of your pictures. This should work. So it may take a little bit of time, but it's not too bad. You can see the speed is, right around 0.25, so it'll only take 4 times as long to convert as it does to play. Okay, so this is done converting, so let's just look at a frame to make sure that we have something that looks good. Yeah, it looks good to me. Now I realize having the naming scheme frame is going to be... Actually, no, I can work with that naming scheme. I'll keep the naming scheme frame. Now we're also going to want to convert the palette video into frames. And the difference here is going to be that the frame size is going to be 16 by 16. So I will ffmpeg -I palette source VF format equals RGB24, crop equals 0.95, whoops, crop equals W equals 0.95 times IW, and H equals 0.95 times IH. I'm going to run minterpolate first, just because I don't really know how minterpolate will work at these really tiny resolutions. So I'll do minterpolate equals FPS equals 60, MI mode equals MCI, MC mode equals AOBMC, ME mode equals BIDUR, VS BMC equals 1. Now I'm going to scale it down to W equals 16, H equals 16, and force original aspect ratio equals disable. I don't think I need to apply a denoiser to this because it's 16 by 16 pixels. It's way too small for noise to even be present. It's optional. You can do that if you want, but I really don't think it's going to make a difference at these small scales. And I'll do what I did before. I'll use lossless JPEG 2000. So CV JPEG 2000, pred1, pixel format, RGB24. And I'll call this palette 04d.png. Whoops, JP2. And let's just view. I'm going to use GwenView. Whoops. Palette. I'll do 500. Actually, can GwenView view? Can it view JPEG 2000? I'll find out. Okay, it doesn't like that. Well, I'll try to ffplay. Palette 0500.jp2. Well, okay, there's our palette. It's there. With ffplay, if I stretch the video out, it makes it blurry. So this isn't a perfect representation of the color palette. It should be blockier. But you did see in my test video that I did earlier that it looks like a reasonable color palette. So we have our input frames for the main video. We have our input frames for the palette video. But we do have a problem. The two videos are different lengths. The main video is longer, and the source that I'm using for the palette is shorter. So exactly how you want to handle the situation is up to you. I've done a few things. As you saw in Weird Al Show, but the color palette is Albuquerque, I handled the difference by drastically speeding up Albuquerque. As you saw in the reverse of that, Albuquerque, but the color palette is the Weird Al Show, I didn't slow down the Weird Al Show. I just decided to loop it instead to fill the time. So what I'm going to do today is I will loop the palette videos to fill time. So let's see, how many frames of our main video do we have? We have 2041 frames of our main video. And how about the palette video? 691. So, how many times do we have to repeat this? 691 plus 691, and then 691 times 3, and we had 2041. Okay, so if we loop the video 3 times, we'll be all set. So, I'm going to write a for loop for A in sequence 691. So this will be all numbers from 0 to 691. Do B equals printf 04 D A. C equals A plus 691. D equals printf 04D C, and then copy palette palette B dot jp2 palette D dot jp2. Done. Okay, well that was really complicated. So what did I just do here? I said for A in seek91, so these backticks mean I'm capturing the output of command, and seek91 means all integers from 1 to 691. What we're doing is I'm saving a variable, printf with this 04D means I'm formatting the number as a fixed set of digits, that's 4 digits. So this will pad the beginning with zeros as necessary. C is going to just be equal to our sequence number plus 691. D is going to be the 4-digit version of that number, and I'm going to copy my original palette frames into this new number. So what this means is that palette 0001 will be copied to palette 0692. Frame 0002 will be copied to frame 0693, and so on and so forth. So this is effectively going to create a whole nother set of frames which are just a copy of the original set of frames, but with the number 691 added. And I'm going to do this again because I have to loop the video more than twice. And I'll just do plus 691. That should work. And we only need up to frame 2041. Let me just verify that that's the case. Okay, 2041. So I'm just going to say for A in sequence 2042, 1, 2073, do RM palette A dot, not a parenthesis or a percent sign, a $sign, palette A dot jp2. So what's happened after all this? Well, if I list my frames, there's 2041 of them. If I list my palettes, there's 2041 of them. This is what we wanted. Do mind you are not required to loop the video, to loop the palette source in order to get it to the same length as the main source. You can time stretch it. For the main video that's going to be using the color palette, I do not recommend stretching it or changing the length. I recommend doing any edits that are time related, whether that's increasing the length by looping, decreasing the length by trimming, or using time stretches. I recommend doing all of that on the palette source video. Now we're going to do our actual application of the color palettes to the input video frames, or the main video frames, I should say. So I will first show you what the command looks like when I apply it to a single frame. I'll say frame 1000.jp2. I palette 1000.jp2. lavfi palette use. You could stop here if you wanted to. I'll show you what I usually recommend. Dither equals Bayer. Bayer scale equals 0. I usually find that using the Bayer algorithm for dithering provides the best general quality, and setting the scale number as low as possible also makes it look better. The choice of what algorithm you want to use is up to you. The only thing is that if you use something other than Bayer, don't use Bayer scale. And I'll call this test.jp2. Actually, before I do that, I'll enforce the proper pixel format. RGB24 test.jp2. So what does this look like? So it looks like our input video, but the colors are different. And the reason why the colors are different is because FFmpeg was instructed to take the colors that were present in entertainment and video and apply it to this frame from Tempo Preschool. So you can see, well, maybe you can't see because it's a little bit small, but you can see there's kind of a checkerboard pattern. And this is FFmpeg spreading out the subsampled colors so that they form even gradients and they don't look as harsh. I wonder what would happen if I said dither equals none. I'm just curious. Okay, so this is what it looks like if you don't apply dithering at all. And as you can see, this is very bad. There are these distinct regions of color that harshly transform into other colors. So you should use some form of dithering if you want good quality. Now I'm going to run a script that will, this is going to do all of the conversions for all the frames I have, but in parallel. Why don't I generate the sequence first? Seq W2041 FFmpeg -I frame .jp2 -I palette .jp2 lavfi palette use equals dither equals Bayer, Bayer scale equals 0. CV JPEG 2000, pred 1, pixel format RGB 24, and I'll call this palette use .jp2. So the first part of the command before the pipe, this is going to generate all of the numbers from 1 to 2041, and this -W means it will set them all to be the same length, so it's going to pad with zeros as necessary. This parallel command afterward is going to run 8 jobs. This you'll have to change based on what your computer is capable of running. It's going to run FFmpeg, where my first input source is the frame, my second input source is the palette, and I'm going to be just doing the same thing I did with that test JP2. Palette use equals dither equal Bayer scale equals 0. I'll render this as a lossless JPEG 2000, and I'll send it to palette use with the number being the same as those used for my input frame and my input palette. So let's run this bad boy. Maybe I should have redirected this to dev null because FFmpeg is going to output these annoying messages, but not too much of a hassle. Okay, so we're done converting all of the input frames to these downsampled frames. Finally, I'm going to show you what it looks like to put together the final video that's going to have all of our frames in a sequence. I'm going to link my corner logo in here. So this is going to be a big one, but I'll break it down as usual. First, I'm going to specify that I want my palette use frames are going to be a single source. So specifying an image sequence like this means a sequence of 4-digit numbers. It's automatically going to convert this image sequence into a video, which is very convenient, but we must set the frame rate to 60 or whatever you chose to use. I usually do 60, but whatever you chose to use earlier, make sure that you put that here as well, because otherwise FFmpeg will default to 25 frames per second. I'm also going to bring in my palette frames. I keep wanting to do PNG, call it force of habit. And I got to put the frame rate 60. I'll do my corner logo, and I'll do main. So the first step. 0 refers to our list of downsampled main video frames. So these are the frames that use the color palette that we specified. I'm going to scale this up to 3840 by 2160. Whoops. H equals 2160. Flags equals neighbor. So we're scaling this up to 4K resolution, and flags equals neighbor again means that we're just going to stretch the pixels out. So the pixels will appear as tiny squares. We don't want FFmpeg to use any kind of blurring or interpolation. It's going to make it look pretty bad. And it also will not make it true to the title. If FFmpeg blurs the video, then it's going to add more colors, and we don't want that. And this is, I'm going to call this PU for palette use. Now, technically speaking, if I just did this, I'd be done. But I think it's a lot better to actually show the color palette that I'm using, so that a viewer can look at the color palette and then look at the video and verify that the two colors between them are the same. So I'm now going to use 1. 1 is my palette frames. I will scale this up, and usually I do 480 by 480. This is a pretty reasonable size, but feel free to play around with this value. I think I've used maybe 640 by 640 in the past, but I think for a 4K video, 480 by 480 is pretty good. And we are going to set flags equals neighbor. so that we don't get blur. I'll call this PL for palette, PU, PL, overlay equals X equals 40, Y equals H minus 40. So what I did here is I'm taking my palette frames and I'm making them an inset over my downsampled frames. I am putting this in the bottom left corner, so the X position is just 40 pixels to the left. The Y position was a little bit harder to calculate, but capital H means the height of the PU, little h means the height of PL, and 40 is 40. So this is going to shift it all the way to the very bottom and then shift it back up 40 pixels. So the bottom left corner of my palette frames will be 40 pixels away from the bottom left corner of the output. And I'll call this both. Then I'm going to put my corner logo in there. That's input number 2. So I'll scale this again to 3840 by 2160. I think that's okay because my corner logo is already widescreen. I'll call this LG for logo, and all LG, wait, I called this both. Overlay. This will be called all. And then finally I want to put the audio back in the video, and that comes from my main. So 3A means audio from input 3. A resample equals 48,000. Playing with the audio isn't strictly necessary, but I do find it's usually better to apply some effects to make it sound better, especially if your input source is very old. A exciter, a FFT-DN, and I'll call this odd for audio. Map odd. I'm going to write a somewhat shorter command line for rendering the final video because I'm just going to be playing this for you. This isn't going to be what I upload to YouTube, so I'm not going to do all those color space, things like that. I'll just say that I'm rendering this with H.264. I'll set the quality pretty high, QP equals 18. And preset medium seems reasonable. Oopsie. I need to map all to this because all is my video, odd is my audio. CV Live 264, QP 18, preset medium. And then I will, however, enforce the proper size just to make sure there are no issues, and the proper frame rate. Then I'll map my audio. I'll set this to Live Opus. And I'll call this output.mp4. This should work. Now this is going to be the most intense portion of this video because I'm doing a lot of upscaling to high resolutions, but we can see it's already gone through a few seconds, so it won't take too long. Okay, we're all done rendering the output. I'm going to try playing it, but usually FFmpeg freezes if I play really high resolution videos, so I may have to shrink this down, but I'll see what happens. I'm just going to play it one more time. It may go on the wrong screen again, so I'll drag it over if I have to. Pay attention to the colors down here and the colors in here. They should always be similar. They're actually the same. Alright, so we did apply the effect successfully. You can see that the palette, which was shown in the bottom left corner, all of the colors in that palette are identical to the colors in the main video now. Do I have anything else to say about that? I pretty much went through all the requirements and such at the beginning. Just, as usual, feel free to play around with this. I will probably do some manual editing on the example video that I just did before I actually publish it, because I think that the audio in the clown or the Jack in the Box logo, I think it's kind of messed up. It's only coming out of one speaker. So you are free to supplement what I did here with other video editing programs. You can use Kdenlive, or if you're on Windows, you can use Vegas or Kdenlive to crop and stretch the video as you desire instead of doing that all through FFmpeg if you don't want to. You can edit the video you can edit the audio of your main video as you so choose in Audacity. I'm going to be using Audacity to do some repairs on what I just played. But otherwise, I think I pretty much covered everything. I hope that this was both educational and entertaining to you. And as usual, feel free to ask any questions you have. And finally, I always say this, but feel free to play around. You are not restricted to doing things exactly the way I do it. I make these tutorials to show you how I do things and some of the decisions that I make to get to these effects. But I do encourage you guys to play around with some of the things I've done here and make your own discoveries. Thank you everybody for your time, and have a good day.